Hello everyone. In these sessions, we will discuss about the different types of the programming methods and also the compensations which are essential parameters in the programming. Now, the first one what we are discussing is with respect to the absolute program. In the absolute program, all the measurements or the dimensions are made from the part origin, which is established by the program and set up by an operator. Any programmed coordinate has an absolute value with respect to the absolute coordinate system 0 point. The machine controls use the part origin as a reference point in order to position the tool during the program execution. It means that the figure shows the one axis, which is one reference plane, which is nothing but the y axis towards the left side. From there only all the dimensions are measured, and even the dimensions which are represented are from there only. In the case of the absolute programming, in the case of the relative programming, the incremental programming, the tool movement is measured from the last position of the tool. The programmed movement is based on the change in position between the two successive points. The coordinate values is always incremented according to the preceding tool location. The programmer enters the relative distance between the current location and the next location. Normally these type of programs is represented, or it has to be represent as a G91, and the schematic diagram shows that the dimensions are referred from the previous to next but not from the initial position. Now the spindle control. The spindle speed is programmed by the letter S followed by the digits. The digits, either it may be a 3 digits or it may be a 4 digits, but normally what they are using is nothing but a 4 digits. There are two ways defining the speeds. The first one is with respect to the RPM, revolutions per minute, or a constant surface speed. The spindle speed in revolutions per minute is also known as constant RPM or direct RPM. The change in the tool position does not affect the RPM command. It means that the spindle RPM will remain constant until another RPM is programmed. The constant surface speed is almost exclusively used on lathes. The RPM changes according to the diameter being cut. The smaller the diameter, the more the RPM is achieved. The bigger the diameter and lesser the RPM. These commands are to be programmed in the execution, and that it has to be used in executing the function. This is changed automatically by the machine speed control unit while the tool is changing the position. This is the reason that is spindle mode is known as the diameter speed. The tool selection T is accomplished as a function followed by a 4-digit number, where the first 2 digits is used for the call the particular tool and the last 2 digits used for the representing the tool offset in the program. Next one is a feed rate control. The feed rate control or the cutting operation may be programmed using a two basic feed rate modes: the feed rate per spindle revolution and as well as the feed rate per time. The feed rate per spindle revolution depends upon the RPM which has been given in the program. The tool radius compensation. The tool radius compensation is to be programmed point on the part in the command point. It is the destination of the point of the tool. The point on the tool that is used for the programming is the tool reference point. These points may or may not coincide, or depending on the type of the tools used in the machine operation being performed. When the drilling and as well as the tapping, reaming, countersinking and boring on the machining centers, the tool is programmed to the position of the hole or the bore center. This is the command point. When the milling a contour, the tool radius center is used with the reference point on the tool while writing the program. The compensation of the tool radius can be either right side or it may be the left side compensation. This can be determined by the direction of the tool motion. If they are on the tool path facing the direction the tool path, and if the tool is to your left, then the workpiece is on your right side. Then the code it has to be used is nothing but G41. For the reverse, we have to use the code is nothing but G42. Both the codes are model in nature and remains active in the program until they cancelled by using another code which is nothing but G40. The canned cycle. The canned cycle is a pre-programmed sequence or it may be a event or the motion of the tool or the spindle stored in a memory of a controller. Every canned cycle has a format. The canned cycle is modeled in a nature and remains active until cancelled. The canned cycle are a greater resource to make a manual programming easier. Often a underutilized canned cycle saves the time and as well as the effort of the programmer. The machining of a rectangular pocket. This cycle assumes the cutter is initially placed over the center of the pocket and the some clearance distance above the top of the pocket, and the cycle will be taken over from the point and plunging the cutter down to the peg depth and feeding the cutter around the pocket in the inner, increasing the increment until the final size is attained. The overall length and as well as the width of the pocket rather than that of the distance of the cutter motion is programmed in the cycle. Now the common G codes normally which are used in the programs are specified or represented in the slide. G00 which is nothing but point to point. G01 is nothing but the linear interpolation. G02 is nothing but a circular interpolation clockwise. G03 is nothing but a circular interpolation counterclockwise. G04 is nothing but a dwell. Like that, there are n number of G codes are there. Depending upon the type of the application, what the programmer has to program, these G codes are used. Even here also it is representing the different types of the G codes. Now M codes, as you know that M codes are nothing but a miscellaneous codes which are used for a particular type of normally the operations. M00 is nothing but a program stop. M01 is nothing but the optional program stop. M02 is nothing but end of the program or the machine stop. M03 is nothing but the start spindle in the clockwise direction. M04 is nothing but the start of the spindle in the counterclockwise direction. These M codes normally represents or executes a particular type of operation. If you take an example of M07, the cutting tool fluid on flood. M08 is nothing but the cutting tool fluid on mist. M09 is nothing but cutting tool fluid is off condition. These are all the some of the M codes and as well as the G codes which are essential in executing the program. Now, what is the difference between the NC and as well as CNC machines? The difference between the NC and CNC machine is a one age of capability. The earlier NC machines performs a limited functions and the movement controlled by the punch tapes and as well as the punch cards. As the technology evolves, the machines were equipped with a increasingly powerful a microprocessor with the addition of these computers, NC machines become to a CNC machines. CNC machines have far more capability than their predecessors. Some of the enhancements that came along with the CNC includes the CAN cycles, subprogramming, compensations, the work coordinates and coordinates cutter systems, automatic corner rounding, chamfering and B-spline interpolations. These are not there in the case of the NC machines. But by using the NC machines, these it can be done very easily.